Welcome to Maths and Science by IITian channel. In this lecture on number theory, I will be taking up a very important topic on perfect square divisors. If there is a number n and if the number of divisors such that the divisor is a perfect square is equal to 7, then what will be the value of n? In number theory, usually n is taken as positive integer. All are integers, and this number of divisors which are perfect squares, if fn is equal to 7, then what can be the value of n? We have to find out the value of n here. For example, for clarity, it's a little bit of good example on perfect square divisors and little bit of advanced topic in number theory, but still we will be solving it. This type of problems may be asked in JEE Advanced, Maths Olympiad examinations and CSIR examinations where number theory is involved. Now, for clarity of the question itself requires a clarity. What is the question given? Solve for all n such that fn is equal to number of elements in the set of divisors of n, where d is equal to perfect square is equal to 7. This is the question given. Now, we will try to understand the question with some examples. Let us say if, because n is a positive integer, it can go up to infinity. We have to find the value of n. If n is equal to, let us say, is equal to 12, what are the numbers or integers which divide 12? Divisors of 12 are 1 is a divisor of 12, 2 is a divisor of 12, 3 is a divisor of 12, 4 is a divisor of 12, 6 also is a divisor of 12, 12 is also a divisor of 12. But out of these, which are squares? That is equal to squares are only 4 and 1. Which are squares? 1 and 4 are perfect squares, because 1 is the perfect square of 1 square. 4 is the 2 square, because it is 2 square. This is 1 square. What is the value of Fn? Fn is a set of 1 and 4, the number of elements in the set of 1 and 4, that is cardinality of set of 1 and 4, that is equal to 2. Fn is nothing but the cardinality of the set of divisors of n such that the divisor is a perfect square. If that cardinality is 7, we have to find the value of n. Usually in common examples of sets in JEE or JEE Advanced, we usually get the question n is given and we have to find out the cardinality. Here cardinality is given and conditions are given, we have to find out the value of n. This is reverse. Question can be framed in any way, we have to solve. Now, let us try to find the solution for it. Here, what are the different types of concepts we use for solving this type of question is prime factorization. Prime factorization concept is required. Multiplicative functions. And we will be discussing about perfect square divisors. And we will also discuss about exponent floor conditions, floor function. And counting of Fn using product formula. We will be using these concepts and developing the solution for the problem. And also here Fn is given as 7. Cardinality of that set is 7. From this, we try to develop the concept basing on number theory and algebra and try to solve this value of n. Because value of n by nature of itself is infinite. All the infinite numbers do not fit into the problem question conditions. And out of the infinite numbers, which are the numbers which are going to fit into this problem? And we have to find out those n values of n. That is the question here. It's a tricky question, a very good question, gives you very good concepts. Let us try to solve. Now, we will go to the main solution using above concepts. The above concepts are already discussed in my previous lectures. Please see those lectures on number theory. Here, Fn is given as number of elements in the set D divides n and D is a perfect square. D is equal to k square is a perfect square, that is equal to 7. We have to solve this. Let us say n has prime factorization. We have done the prime factorization. Assume n is equal to is a positive integer. Let us say it's a positive integer, and we are not aware what is n, and we have factorized it. We have done the prime factorization. What is prime factorization? From the least prime to the possible primes, we'll factor it. And n is prime factorization we have done. Prime factorization done in n. For prime factorization, please refer to my earlier lectures. If n prime factorization done, that implies let n is equal to P1. First prime factor is 1, P1. It has an exponent of A1. P2 has an exponent of A2 up to Pn factorization prime exponent. This is Pk, let us say, and exponent as Ak. For example, d is equal to n is equal to 12 we have taken. In that, what is that we have done? 12 is equal to, let us say, 4 into 3. That is equal to 2 square into 3. This is the smallest prime factor SPF, which I have discussed in my previous lectures, to the power of some A1. Here it implies P1 is equal to 2, A1 is equal to 2, and P2 is equal to 3, and A2 is equal to 1. Do you agree? Any number can be expressed in this way. Any number n can be expressed as P1 to the power of A1 into P2 to the power of A2 into P3 to the power of A3 into up to Pk to the power of Ak. This is called as a prime factorization process. Please get the clarity on it. This is the most important step. Now, we are not interested in odd numbers of A1, A2, A3. We are not interested in odd numbers because D should be, the prime factor should be a perfect square. For a prime factor to be a perfect square, prime factor should be a perfect square. For the D divides n, the divisor of n is a perfect square. Here 4 is a divisor. You see here, this 4 is a divisor. It's a perfect square. That means the perfect square D can be written as divisor. From the definition of the problem, we can write it as P1 to the power of B1, P2 to the power of B2 up to Pk to the power of Bk. Are you able to understand? All the divisors are not perfect squares. All the divisors are not perfect squares. That means the exponent of the prime factor should be an even number, or the values of P1, P2, P3 should have an even number as the exponent. Hence here we have found D is equal to P1 to the power of B1, P2 to the power of B2 and Pk to the power of Pk. And here, for example, to get the clarity on the number n is equal to 12 taken. Same example. N can be written as 2 to the power of 2 into 3 to the power of 1. These are divisors. But D should be some P1 to the power of B1. The divisor should be a perfect square. For D should be a perfect square, D should be 2 to the power of 2 only. It cannot be 3 to the power of 1 because 3 to the power of 1 is not a perfect square. Are you able to understand? Now, the number of perfect squares are, this can also be, n can be written as 1 square into 2 square into 3 to the power of 1. Here D can be 2 square into 1 square. Now, we have to find the condition between A1 and B1 or A2 and B2, which implies BI is even. Do you agree? BI is always even. And BI is a positive integer. BI is equal to even. BI is equal to greatest integer of AI by 2 plus 1. I am not talking about only number 12. It is for any number n. If it is written in this form, n is equal to P1 to the power of A1, P2 to the power of A2, P3 to the power of A3. The number of exponents in n, when it is written commonly, will be more than the number of exponents in D. P is a number, it's not a perfect square. But D is a divisor, which is a perfect square. D is a divisor, which is a perfect square. And it has P1 to the power of B1. Don't confuse with P1 is there in N is P1 in D also is same. No, they are different. It is a generalized, these are all generalized equations. The number of exponents in D will be half of the number of exponents in N for the prime, after the prime factorization, and the equation Bi is equal to Ai by 2 plus 1. To avoid the fraction, we will put the greatest integer, that is floor function. Now here, what it is given, Fn is equal to number of elements in the function d divides n such that d is equal to perfect square. is equal to 7. We have defined what is n and what is d. From the definition of n and k, n and d, we can find out d is a perfect square. Fn can be written as product of, what is d? D is a product of bi, exponents. It has some pi to the power of bi, pi to the power of bi. What is bi? ai by 2 plus 1. Fn is equal to the number of divisors which are perfect squares. That Fn can be written as product of I is equal to 1 to k bi. Do you agree? That is equal to product of I is equal to 1 to k. What is bi? ai by 2 plus 1. Sorry, this greatest integer should be this, for this only, plus 1. This is what is given. Now, we have been given the value of Fn as 7. That implies product of I is equal to 1 to k, greatest integer ai by 2 plus 1 is equal to 7. This is the condition that should be fulfilled, and we have to solve for n here. If k is equal to 1, that implies a1 by 2 plus 1 is equal to 7. That implies a1 is equal to 7 minus 1 is 6, that is 12. This we have forgotten the greatest integer to write it here. When you write the greatest integer, then it can be 12 or 13. We will have a value of n is equal to p to the power of 12 or n is equal to p to the power of 13. Now, if k is equal to 2, what we have done? We told that product of I is equal to 1 to k is equal to 2 here. ai by 2 greatest integer value plus 1 is equal to 7. That implies a1 by 2 plus 1 into a2 by 2 plus 1 is equal to 7. Already a1 by 2 plus 1, that is greatest integer we have to write here. a1 by 2 plus 1 into a2 by 2 plus 1, sorry, this here, is equal to 7 implies we have already got the value of a1 by 2 plus 1 is equal to 7. Hence, this a2 by 2 plus 1 will be 1 only. A2 by 2 plus 1 is equal to, that value will be 1, because it is already 7 and the product of these two is 7. That implies a2 by 2 is equal to 0. But we know a2 is always greater than or equal to 1. That implies a2 is equal to 1. That says n is equal to a1, a2 are exponents. Please try to understand. P1 to the power of a1 into P2 to the power of a2 is equal to, what is the value of a1? P1 to the power of a1 is either 12 or 13 into P2 to the power of 1. a2 is equal to 1. That implies this is equal to P1 to the power of 12 into P2, or n is equal to, it can be P1 to the power of 13 into P2. P1 and P2 are primes, they are not equal to each other. Where P1 and P2 are, where n is equal to defined as P1 to the power of a1 into P2 to the power of a2 into P3 to the power of a3 up to Pn to the power of an. From this definition, we have got the value. Similarly, when k is equal to 3, it also implies n is equal to, similarly, you can try P1 to the power of a1 into P2 to the power of a2 into P3 to the power of a3. When k is equal to 3, that will be P1 to the power of a1 into P2 to the power of 1. Because a2 is 1, we will get in the similar logic P3 also 1. That implies n is equal to P1 to the power of 12 into P2 into P3, or it can be n is equal to P1 to the power of 13 into P2 into P3, where P1, P2, P3 are distinct primes. Similarly, for k is equal to any value. K is equal to any value, then on similar terms we get n is equal to P to the power of 12 into some m, or n is equal to P to the power of 13 into m, where m is equal to square free and has only square free, such that the GCD of P and M is equal to 1. Now, what is the solution? The solution is, final solution Final solution is n is equal to p to the power of 12 into m, or n is equal to p to the power of 13 into m. Under the condition GCD of p and m is equal to 1. This is the general answer when Fn is equal to 7 and the divisor of n is a perfect square, and number of divisors of perfect square is equal to 7. This is the answer. And to make it clear, let us take a number 4096. N is equal to 4096. What are the divisors here for 4096? I have already explained you how to find out the divisors. What are the divisors? There are many divisors which you can easily find out. N is equal to 4096, that is 2 to the power of 12. And what are the perfect square divisors? 1, 4, 2 to the power of 2 is a divisor, 2 to the power of 0 is a divisor, 2 to the power of 2 is a divisor, then 16 perfect square divisors only we wanted, not others. In between we have many divisors, we neglect those divisors, we will take only perfect divisors. 1, 4, 16, 64 is a perfect square, 256 is a perfect square, 1024 is a perfect square, and 4096 is itself a perfect square. How many are there? 1, 2, 3, 4, 5, 6, 7. Here Fn is given as 7. N is equal to p to the power of some value a into m. And when Fn is equal to 7, it implies the value of a is equal to p to the power of b, let us call instead of a. You will get confused unnecessarily. P to the power of b. The value of b is equal to a by 2 plus 1. If m is equal to 1, let us say case 1, n is equal to p to the power of b into 1, that is equal to p to the power of b. That p to the power of b is nothing but smallest p is 2, 2 to the power of 12. That means either we should get either 12 or 13 as the power of p. If you take the smallest in prime number, prime factor, then it is 2 to the power of 12. That is equal to 4096. Where we have perfect square divisors as 7. For a number 4096 is if m is equal to 1, b is equal to 12. This is the answer. This is how we have to find out the perfect square divisors for a given number. If the number of perfect square divisors of a given number is equal to 7, it should be converted into a form where n is equal to p to the power of b into some m value, and that if it is fn is equal to 7, it should be either p to the power of 12 into m or p to the power of 13 into m. It should be either b should be either 12 or 13. That's what we have got here as a final solution. That means n should be p to the power of 12 into m, or n should be p to the power of 13 into m if fn is equal to 7. And as a homework, please try and solve for n such that fn is equal to some 9. In the similar way, you please try to find the value of n such that fn is equal to 9. With this, I wanted to conclude this lecture. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. It's a very good conceptual lecture. Please pay attention to it. If required, you please see it again and again. And if any doubts are there, please come back to me in the comments column. I'll reply to them. Best of luck. Thank you for listening to me. If there is a value addition to you because of this lecture, kindly hype this lecture, share this lecture, and subscribe to my channel Maths and Science by IITian. Thank you. Best of luck.